The systemic and pulmonary arterial systems distribute blood to the capillary beds throughout the body, and the resistance and pressure differs in the vessels across the circulation. So let's take a look at those differences. So the heart pumps blood through this complex system of blood vessels. And here on this graph, we're looking at differences in resistance and pressure. So pressure is on this line here, and that's systolic and diastolic, and relative resistance is indicated here by these blocks. So the very high pressures that are generated by the contraction of the left ventricle is the force that drives blood through the systemic vascular system and to all of the organ systems. And if we look at the relative resistance, we can see that the aorta and the large arteries offer little resistance to blood flow, and that's primarily due to their large diameters. And as a result, the blood that flows through the aorta and the arteries, there's only this really small decrease in the hydrostatic pressure. So because there's little resistance in these vessels, the high pressure generated by the left ventricle is maintained. However, in the arterioles, that changes, and arterioles are also known as resistance vessels, and they offer this large amount of resistance to blood flow, as we can see here. And because of this large resistance, there's this large pressure drop as blood flows across the arterioles. So with this high resistance, we get a large drop in pressure. And as we'll see later, not only is the arterial resistance high, but it's also highly variable and possible to regulate. So now we arrive at the capillaries, and the capillaries offer some level of resistance, but maybe not as much resistance as you'd expect given their very small diameter. And the reason that the resistance of the capillaries is relatively low compared to the arterioles is because we have so many capillaries. So there are lots and lots of these very small capillaries in parallel. And because there are so many capillaries with a very large surface area, the aggregate resistance of the capillaries is not as high as the aggregate resistance of the arterioles. And finally, the venules, veins, and vena cava are very low resistance vessels as the blood returns to the heart and the right atrium where it gets ready to be pumped into the pulmonary circulation. So on the previous image, we were looking only at pressures and resistances in the systemic circulation as blood is pumped from the left ventricle through capillary beds of the various organ systems and back to the right atrium. But here we're looking at pressures of the systemic circulation, and we've also added in the pulmonary circulation as the right ventricle pumps blood through the lungs back into the left atrium. So in the atrium, the pressure is always very low, but as the ventricle contracts, there's this steep rise in pressure. And the aorta and arteries, both large and small, transport blood with a relatively low resistance to flow, and they deliver blood at pretty high pressures from the heart to the arterioles. And then in the arterioles, there's this marked drop in pressure, and that's due to that high resistance of the systemic arterioles. And remember that this resistance is also variable and can be regulated. Then there are these capillaries, which are individually the smallest of our blood vessels, but there are so many that the total cross-sectional area is the greatest. So there's a slight pressure drop here. And then there are the veins, and the veins are the low resistance vessels with a high capacity that return blood to the heart. And then we're back to the right atrium and in the pulmonary circulation, which is a low resistance, low pressure system compared to the systemic circulation. So as the right ventricle contracts and creates this relatively low pressure, blood flows through the pulmonary circulation, and because of the frictional resistance of the blood flowing through the vessels, there's this steady decline in pressure, and the pulmonary venous pressure is essentially the same as the left atrial pressure. So a few important takeaways we've reviewed are listed here. And also really notice that the pressures and the pressure gradient across the pulmonary circulation are much lower than those of the systemic circulation.